Today we're going to talk about species interactions and specifically prey-predator systems. Prey-predator systems are a type of consumer resource relationship, and they are actually cover quite a wide range of classic predations and grazings. And among the consumer resource relationship, there are also parasites and pathogen. Let's have a quick look how what are the similarities and the differences among these different type of consumer resource relationship. And we're going to look at depending upon the number of prey that are consumed in the lifetime and the specific type of interaction. Predation is the cruisome predation actually of a gray-white shark and seal is what usually comes to our mind when we think about predation in the oceans. The predator usually kills a prey immediately after attacking, consume multiple prey individuals during the lifetime, and predators are usually larger, bigger, of a bigger body size than their prey. Now, the gray-white shark and seals that is reported here in the figures is the classic one, but starfish are actually really effective keystone predators that might actually shape basically the community ecology. And whales, of course, with their specific type of feeding behavior, they actually are able to ingest huge quantities of krills. These are the type of prey-predatory relationship that we're going to see most here. Plus, will include also grazers. The grazers usually consume only a part of each prey. They usually, or they not necessarily kill it entirely, and they attack multiple prey during their lifetime. Slightly different are the parasites. Whether it's the tongue eating loose or whether they're the prey of salmon or vibrio, in oysters. Parasites have a long-lasting relationship with their host. They usually do not kill their host. The pathogen, of course, they do kill them eventually, but generally not immediately. It's not the type of, really rapid death that seals, unfortunately, my experience after being attacked by a shark. The parasites consume only a part of their host and they attack sometimes only one or few individuals in the lifetime. And most importantly, parasites and pathogens are usually smaller, much smaller than their host, and they have, this really long-lasting, intimate relationship with their host. Describing host-parasite relationship requires its own type of models, and today we're going to look at mostly at classic prey-predator relationship. How do we study that? How can we infer the impact of consumers on their resources and the population? Well, there are, classically, at least, two big categories of approaches. The certainly most important one is observation. In ecology and natural history, looking at the environment, what happened there, keeping track, and making experiment is always the number one things that need to done and inspire us question and allow us, in fact, to run experiment, remove consumer, for instance, observe changes in resource, species, population dynamics, or demographic rates. In terms of observation, a very interesting story, in fact, that it's worth keeping in mind that is reported here is basically the conversation that Vito Volterra, who was already a very famous mathematician in Italy, had with his son-in-law, the zoologist Umberto d'Ancona, who's represented here actually in the lower picture there. And Umberto d'Ancona has noticed a change in the landings in Venice, in Trieste, and in Fiume during the big war. And you can see here, in fact, that the fraction of large predators or sharks basically in the landings in the fish market of all these places had increased remarkably during the big war, the First World War, when basically the most of the fishing activities were just scaling down dramatically because of the war. And they started again after the end of the war in basically 1920 when immediately the fraction of large predator drop down. And the question then that we want to answer here, what does generate this type of oscillatory dynamics, and under what conditions a predator coexists with its prey, and what characteristic the short-term dynamics as well as the long-term equilibria, if any, of course, of predator-prey system. So we want to try to address some of the questions in the next basically hour.